my name is Mansvi and today we will be discussing about structure of atom. These are all the topics that we are going to discuss. First, this Dalton postulates, then structure of atom, under which we will be studying about Thomson's model, Rutherford's model, Bohr's model, and under Bohr's model we will be studying about shell, valency, atomic mass, and number. So first, Dalton's postulates, which were written by Dalton in the year 1803. Dalton was an English chemist and physicist. He gave the following postulates about atom. Elements are composed of small indivisible particles called atom, and all atoms are the building blocks of all the matter that surrounds us. Atoms of the same elements are identical, but atoms of different elements are not identical, which means that atoms of the same elements, according to their mass and their chemical properties, atoms of the same elements are identical, and atoms of different elements are not identical. Atoms of different elements join together in simple proportions to form a compound, example CO2, where one atom of carbon and two atoms of oxygen are present. And last, we have in a chemical reaction, atoms are rearranged to form a molecule. These postulates were not based on any experiment, and that's why these are called postulates. Next, we have structure of atom. The first is Thomson's model, which was given by Thomson in the year 1897. So, Thomson's atomic model is also called plum pudding model, and we'll see the diagram. Why is it called plum pudding model? It is because, like the toppings of the plum pudding are distributed unevenly. So the negatively charged electrons are distributed unevenly above the positive sphere, and the electrons are negatively charged. Thomson's cathode ray tube test demonstrated that all atoms contain small negatively charged subatomic particles or electrons, which means that due to the Thomson's model, we got the discovery of negatively charged electrons. Although Thomson's model explained that atoms are electrically neutral, the results of experiments carried out by other scientists could not be explained by this. Next, we have Rutherford's model, which was given by Rutherford in the year 1912. Ernest Rutherford designed an experiment to prove how the electrons are arranged within an atom, because in the previous one, we know that the electrons were unevenly distributed, but to have a more definite, uh, to know how the electrons were arranged, he designed an experiment. So for this experiment, he selected a gold foil because he wanted as thin layer as possible, and the gold foil was about 1000 atoms thick. In the experiment, since most of the particles went through, which means that in this experiment there was a radioactive source, and this was the gold foil, and there was a beam of alpha particles, and this was the detector. And when the beam of alpha particles was thrown into the gold foil, most of the particles went through it, which means that the atom is mostly empty spaces. So, we also came to know that the few of the positively charged alpha rays get deflected by very dense positive beams, which is nothing but the nucleus, and the result was very different from what we had expected. Discovery of protons or positively charged ions was also done through this model. There was one drawback, which was that this model could not explain the stability of an atom, because according to this model, atom could only survive for 10 raised to the power minus 12 seconds. Next, we have Bohr's model, which was given by Bohr the next year after Rutherford's model, which means 1913. In order to overcome the objections raised against Rutherford's model of the atom, Niels Bohr put forward the following postulates about the model of an atom. So, in order to overcome the objections, he gave the following postulates, which were the first one was that only certain special orbits, known as discrete orbits of the electrons, are allowed inside the atom, and these orbits or shells are also called energy levels. And while revolving in discrete orbits, the electrons do not radiate energy. These are the things that Bohr put forward. And with the help of this model, we came to know these three things. Each orbit has a specific energy. Electrons are present on the specific energy level and they cannot radiate energy. And stability of atom was also explained through this model. But there was one drawback. It was that this model could not explain the details of the hydrogen and helium atomic spectrum. Now we'll be discussing about shell. The shell is basically the orbits that revolve around the nucleus in an atom. The general formula is that the nth shell can, in principle, hold up to 2 n raised to the power 2 electrons, which means that the first shell has 2 electrons, the second shell has 8 electrons, and so on. These shells are named as K, L, M, and N, and so on. Next we have valency. Valency is the number of atoms of a particular element that is combined with one atom of another element to form a molecule. Valence electrons are the electrons located at the outermost shell of the atom. For example, if we take the example of fluorine, fluorine has 7 valency electrons. It needs only one electron to become octet. Next we have atomic mass and number. Atomic mass is associated with the number of neutrons and protons that are present in a particular nucleus of an atom. And here we have taken the example of lithium. The second point is that atom number is usually the number of protons present in an element's nucleus. Atomic number is equal to the number of protons, and mass number is equal to protons plus nucleus. So here we have taken the example of lithium where the atomic number is 3, which is equal to the number of protons, and mass number is 6, which is equal to protons plus neutrons. So the number of neutrons is 3 and the number of electrons is also 3. Now these are the key points of the whole discussion. Shells of an atom are designated as K, L, M, N, and so on. Valency is the combining capacity of an atom, which means that when two elements are combined, the valence electrons are taken in consideration. Credit for the discovery of electron and proton goes to J.J. Thomson and E. Goldstein, respectively. And Rutherford's alpha particle scattering experiment led to the discovery of the atomic nucleus, which is atomic nucleus is very hard and it is dense, and it also consists of protons. Elements are defined by the number of protons they possess.